Hello, everyone, and welcome back to CSE 373. In this lecture, we're going to continue our discussion of algorithmic analysis, which, reminder, we talked about code modeling and asymptotic analysis in lecture 4 as kind of two parts of that pipeline. And today we're going to build off those. We're actually going to make each one of those tools a little bit more powerful by giving you some options of different ways that you could do asymptotic analysis or different ways you do code modeling. And this should hopefully be able to handle a much bigger set of algorithms and code that we want to analyze that just asymptotic analysis with our simple code modeling we introduced on Wednesday and Big O just can't handle. In this video, though, I'm not going to actually talk about any of the new things. I have a couple announcements I want to share, and then I actually want to talk a little bit about your Project 1. So, some announcements. Project 1 came out on Wednesday, and it's due 1 week from then, next Wednesday, at 11:59 Pacific time. Please remember to read the partner setup instructions if you're working with a partner. Oh, and that was supposed to be a separate bullet right there. But there's also that Project 0 extra credit opportunity that's due at the same time as Project 1 to let us know a little bit about the setup that you did for Project 0. I'm going to introduce what Project 1 is in just a second, but I have just a few more things to remind us about. One thing that is a little bit different about this class is that you have projects for like the coding aspects, applying what we talked about to practice, but we also want you to get practicing with some of the conceptual things we've talked about. And so we're going to be releasing exercise 1, which is a written homework, and it should be done individually. And it's going to be released Friday and due on Friday. So a normal schedule for exercises is Fridays to Fridays, and they're weekly-ish, meaning that they're going to be happening most weeks, or a lot of weeks, but there's definitely some weeks we have off from exercises. And really, if you're staying on top with the material, like you're watching the videos beforehand, you're coming to class to get practice, you're going to quiz section, you should be able to do these problems and these exercises, because we design all the problems we do in class to help you do these types of problems on the exercise. So that's just one thing to remind you about, that also exists. And the last thing to remind you about is when you're coming to class any day from now on, please remember to sign up for a class session group on Canvas. If you don't remember how to do that, we have instructions on the course website. But that's going to be really helpful with us getting those pre-assigned breakout rooms and making sure that you have a community in the course that you can go back to again and again. And again, you can always change those at any point in the quarter if you choose. So I want to talk a little bit about Project 1. So for Project 1, it's all about this new ADT that we haven't taught you before called a DEC, or a double-ended queue. I feel like they should have called it a DQ, but the abbreviation ended up being DEC. That's what most people call it. A double-ended queue is just like a queue that you're used to, except you're able to add and remove from both the beginning and the end. So it's kind of like halfway between a queue and a list. The big difference is that DECs are, you can't change them outside of the beginning and end. So this, you could see here, we have a specification for what is the DEC ADT, and its state is the collection of items and the count of items, and the behavior is add first, add last, remove first, remove last, size is empty, and we also include a get method. And so that seems more like you can get something out of the ith index. That seems more like a list, but it's different because we don't allow the client to modify anything in the middle. So we use a different ADT for this. And this is a pretty useful ADT. So your project is to make implementations of this DEC ADT. This project is going to be building on the structure of differentiating ADTs and data structure implementations. And it's also going to be reviewing queues because a DEC is very similar to a queue. And you get to do a little bit of asymptotic analysis. So this could be practicing the techniques and analysis that we covered in Lecture 2 and Lecture 3. Lecture 2 being about ADTs and lists. Lecture 3 being about stacks, queues, maps, and ADTs. This project has 3 parts. The first 2 parts are implementing array DEC and linked DEC. One thing that we're going to be doing a little bit different for this assignment is we actually give you a solution to array DEC. The problem is it's a buggy solution. It doesn't actually work. And so for the first part of the project, for the array implementation, it's already done, but your task is to figure out what the bugs are and fix them. Which is, if you go into industry, that's actually a pretty common task where you have to go fix someone else's code that's buggy. And then for the second task is implementing a linked deck from scratch. So it's that linked list version of the structure. You're going to be implementing that from scratch with your partner. And then the third part is a bit shorter. We're going to have you run experiments. So there's a section on the specification about how to experiment with your code and try it out on different input sizes and tell us what you think about the empirical results and how that matches up with your conception about how Big O works and asymptotic analysis works. So hopefully you find that useful. One thing I want to give you a bit of a hint about, and this is all of these things are described in the spec, is talking about how to implement that linked deck. So are you tired of running into null pointer exceptions in your code? Are you tired of having to write code for a bunch of different cases, like if one is front is null, or having a back case or a middle case or another middle case? You know, if you see yourself in one of these grayed out infomercial commercials, then I have a solution for you. We're going to introduce this idea of a sentinel node in your linked implementation of the linked deck. The big idea is that we're going to put two dummy nodes at the beginning and the end. Those nodes don't have any data, like they're not going to store anything meaningful. We're just going to use them as bookends. And so now when we do this, you never have to change the front and back pointer of the linked deck. They just always point to the sentinel node. The benefit that gives you is now every node with real data, notice in the client view, this list only has 3 and 9 as its elements. Even though there are 4 nodes, 2 of those are sentinels. We only look at the 3 and the 9 in the middle. Now every node in the list is a middle case. So you don't have to have special cases all over the place for like, oh, if this was front or if front was null. And hopefully this should simplify your solution a lot. Because there's going to be a lot of complexities, like the fact that you have to deal with the front and the back pointers. And we're going to be making this a double A linked list, meaning each node has a forward pointer and a backwards pointer. And so that's a lot of things to keep track of. And we want to make sure that you can simplify this in some sense by allowing these sentinel nodes. Now, the whole point of this is to reduce your how complex your code is and hopefully prevent bugs. So we're trying to encourage you to use this approach because it's simpler. Now, there is a trade-off. Like, this isn't for free. It uses a tiny amount of extra storage space. You need to create 2 extra objects. But I would argue in our context for 373 right now, the amount of savings you get from time and effort for debugging and having this gigantic, ugly code, saving that is so much more worth having extra 20 bytes of memory or something like that. So we're going to be okay with this trade-off for this assignment. So please use those sentinel nodes like we suggested. Our diagrams show you what the state would look like after that. So that's an important thing. Okay, a couple other things I want to mention about the project. So I want to talk a little bit about Gradescope and submitting on Gradescope. So from this project onward, we'll have some Gradescope only tests. What we mean by that is when on Project 0, we gave you a local version of the test suite that you could run, and then you saw any errors locally. And then when you pushed to Gradescope, it was the exact same thing. We did have a couple extra tests, like making sure your system built correctly, like those dependency checks, but the like behavior checks were all visible from your code. From now on, we're gonna withhold some tests and keep those only on Gradescope. So you'll only get feedback about some behaviors of your program when you submit to Gradescope. When you submit to Gradescope, you'll get your grades. The tests are public, you can see them, but they only live on Gradescope. Now, why are we doing this? We want you to start practicing reasoning about your code and writing your own tests. This is such a crucial skill for working in software and developing complex projects. So we want you to start building up the practice of writing your own tests. So use Gradescope tests as a double check to make sure that the tests you are writing are thorough enough. So in this assignment, you should be writing extra tests so that you can test your behavior. If you write some tests, and we have some tests there locally for you, and it says it all passed, and then you submit, and then Gradescope reports that you have some errors, that's a great indication that you need to go back and write more tests to recreate the error. So we have a little workflow that we recommend. You start writing your implementation. Think about the edge cases while you're writing your implementation, and start writing tests for those. Like, oh, what if the list was empty? What should this do? And let's make sure I handle that correctly. Then you run your own tests, and if you pass everything, that probably seems good. And then at the end, you submit to Gradescope as a double check, and you might see that you fail more tests, which means you need to go back to the drawing board in terms of writing tests to recreate those errors. Now, this can be a little bit more of an iterative process too, right? Where you don't have to write the entire implementation first. You might write it bit by bit and test bit by bit. That's also totally fine. But the thing I want to stress is when you get failures on Gradescope, your first instinct should be, what test can I write to recreate this failure? Because then once you have the test locally on your computer that you wrote, you can now debug it and figure out what's going wrong. One technically valid way of doing this is to not write any of your own tests and just push to Gradescope every single time and then see the errors or not. The problem is, for these Gradescope only tests, we only show you the name. We show you a hint at describing what test is happening, but it's going to be impossible for you to debug. And so that is not going to be a fun experience for you. You're going to be submitting really, really frequently. But use that failure, the description of what the test is testing, the case it created, as a hint towards, oh, okay, what can I do to write a test to recreate that? Before coming to office hours, with saying, asking like, oh, I submitted to Gradescope and I posted a bug, and I had a bug, or before we post on the message board, this test on Gradescope is failing, you should start by writing a test to recreate that locally. That's going to be the first thing we're going to help you with whenever you come to office hours or the message board. It's like, hey, let's talk about strategies for figuring out what case is failing here and how to write a local version of the test to recreate it. Because seeing a failure is easy, right? You go into Gradescope, you see the failure there. But figuring out why something fails is a very important step that you need to solve before trying to fix the bug. And so that we're trying to be intentional with forcing you to think about that why by writing your own test to recreate these Gradescope errors. We're trying to help you improve on process. We're not trying to make this extra difficult on you or something, but this is a really important process to get right early. But yeah, so while I said it's like kind of technically valid to go through this assignment without tests, I said technically valid, we don't allow that. So we're going to be asking you to be writing your test, and before you get help, you need to write a test for this thing. And again, if you're a bit confused on how to write a test for something, come to office hours. We'll help you write that test. But do remember, we're thinking about helping you develop testing skills, not just telling you how to fix your bug necessarily. Okay, a couple other Gradescope logistic things. You can submit your assignment as many times as you want. We will always use your last submission on Gradescope. One thing we're going to be doing is to kind of encourage this pattern of writing your own tests. We impose a slight rate limiting system that shouldn't actually hinder you, and it should actually help you more than hinder you. You're only allowed to submit about 6 times an hour. And if you start submitting more than that, then we'll ask you to wait a bit. And part of the reason is if you're submitting 6 times an hour, you might be kind of stuck on something. And so this is a good time to encourage you to take a break, take a step back, maybe think about your own test. The intention is to not get in your way. The intention here is to give the server a little bit of a break so you're not uploading 100 submissions a minute. And guessing and checking is not an effective way to learn these concepts. We want you to think thoroughly. And so you should not be limited by this, but we want to encourage you to be a little bit more thoughtful in your process. And then last thing I want to mention about Gradescope is the grade you see on Gradescope is your final grade for this project, except there's a small bit of manual grading for your experiments for that part 3 write-up. And that part we don't auto-grade because we have to grade that by hand. But yeah, so that Gradescope grade that shows up on Gradescope is your grade for the code grade for project 1. Okay, last thing I want to mention with working with a partner, there are instructions on grades on the course website about collaborating with your partner. We recommend that you add each other to your GitLab repositories. We have instructions for how to do that. You just go into GitLab and add them as a member. Probably the easiest thing is to just work on one person's repo. So say if Amanda and I were working together, we might decide that Amanda's repo is the one we're going to work on. And then I would set up my own local copy of her code if we're partners so that we could work together on that. We have some tips for how to collaborate with Git. Our recommendation for partner work is that you do pair programming. So sit down together, not actually physically, but like on Zoom or Discord or whatever, and talk through your code with each other. Two heads are better than one, especially when spotting edge cases. So one recommendation usually is to switch off between who's being driver and who's being navigator. So one person types and is like actually writing the code for some parts, and the navigator is spot checking and helping design the system and give suggestions about, oh, do we think about this case? Or this is what I think this code should be doing at a high level. So they're more like the narrator. But make sure you're switching so you both get a chance to try both of those roles. Meet in real time. Consider screen sharing so that you can actually see the code that you're working on. And please remember to be kind. Collaborating in our online quarter could be so difficult because we don't actually get to be face-to-face. So please be patient and understanding. Partner projects are awesome if you can work well with your partner. And part of that is, if something's coming up on your end, maybe try to communicate with your partner that, hey, I kind of needed the day off today. I can't really work on this today, but I'm definitely okay to work tomorrow. But one thing that can be a little frustrating is the radio silence. But also, if you're the partner that's not hearing back from someone else, please try to be a little bit patient. They might be going through something right now. So again, just remember to be kind and patient with each other. One last thing to mention about projects is we don't intend the partner projects to be just split the project in half and then go your separate ways. We expect you to understand the full projects, not just half. So please don't say like one person does array deck and the other person does linked deck. Because we really do want you understanding these full parts. Part of the reason to implement these things is to build up your understanding of how to do these implementations. And if you only do half the project, you miss half the learning. So please don't do that. It's not really a great look when you come into office hours and say, hey, our project's broken, and we ask you about, okay, what's this code doing? And you said, well, my partner wrote all of this, so I don't understand it. Can you debug it for me? We'll probably say, hey, can you go actually talk with your partner for this first, and then we'll come back. You can come back and we'll help you. That's all I want to share about the project details. All of this stuff was in the spec, but I thought it'd be good for us to walk through this together.